The new topic is force on a current carrying conductor in a magnetic field. As you know that when electric current passes through the good conducting substance, then it behaves like a magnet and magnetism or magnetic field is produced. Because of this magnetic field, a force can also produced. A force is produced on the magnet as well as other conductor. For the first time, Andre Ampere performed this experiment, and he tried to prove that when current passes through circuit, conductor behaves like a magnet, and under the effect of magnetism, force is also produced. See. Stand. On this stand, with a wire, an aluminium rod which is called good conductor is suspended. Okay? With this aluminium rod, if you connect electric circuit, battery and key. Okay? Now when you know that it is very easy and you learnt it, when electric current passes through the circuit from positive to negative, it's a good conducting substance, so current flows in this direction and then come back to negative pole. At that time, when current passes through aluminium rod, this is aluminium rod, stand. Okay? At that time, when current passes through this aluminium rod and aluminium rod behaves like a magnet, at that time, if you bring horseshoe magnet, means permanent magnet, okay, like this, near to this aluminium rod, what happened with this aluminium rod? This is north, this is south, okay? When current passes through aluminium rod, the first step is when current passes through aluminium rod. Aluminium rod behaves like a magnet. So magnetism is produced surrounding this aluminium rod. Means in the aluminium rod, magnetism is produced. If magnetism is produced, we can say that polarity also forms. This is north pole and south pole. Suppose this upper side is north and the downward side, like this is aluminium rod, the upper side is north and downward side is suppose south. So, poles are also produced. Okay? At the same time, if you bring permanent magnet, at the same time, when you bring permanent magnet, nearer to the aluminum rod, then what happens? You know that like poles, north and north, south and south, repel with each other, and opposite poles attract with each other. So, repulsion, or suppose we say that current flows in this direction, and suppose this layer or this surface is south and this surface is north, then south and south, north and north repel with each other. Suppose this surface is north and this surface is south, and north and south, south and north attract with each other. In short, repulsion takes place or attraction takes place. If repulsion takes place, then this aluminum rod try to move away. And if attraction takes place, this aluminum rod try to move towards the magnetism. Okay? Simple thing is that. So, at that time, this aluminum rod what happened with this aluminum rod? Aluminum rod feels attraction or repulsion. Rod feels attraction towards permanent magnet or repulsion repulsion away from the permanent magnet. Okay, this is a simple experiment. On the basis of this, scientist Fleming, this experiment is performed by Ampere, Andre Ampere. But from this experiment, scientist Fleming gave us a rule known as Fleming's left hand thumb rule. Fleming's left hand thumb rule. Right? What is Fleming's left hand thumb rule? Forefinger, middle finger, and a thumb. Forefinger, middle finger, and a thumb. If these three stretch perpendicular to each other, then forefinger shows what? Direction of magnetic field. Middle finger shows the direction of electric current, and the thumb shows the direction of motion of conductor. Here conductor is aluminum rod. Current flows like in this direction. So magnetism moves perpendicularly. Okay, and this motion of means it moves this way or this way. Means repulsion moves away and attraction moves towards the magnet. Right? So if what is Fleming's left hand thumb rule? Forefinger, left hand of means forefinger, middle finger, and thumb of the left hand. Stretch such that all three are mutually perpendicular to each other. Then middle finger shows the direction of electric current. direction in this way, side, direction of electric current, forefinger, shows the direction of magnetic field, at that time thumb shows the direction of motion of conductor. This is Fleming's left hand thumb rule. Okay, so diagrammatically we can show that this is the direction of magnetic field. This is the middle finger, direction of electric current, and thumb shows the direction of motion of conductor. Fleming's left hand thumb rule, just like this. Okay, so write down all this board work. Afterwards we will start electric motor.